All right, so this is going to be a pretty quick slide, but what I want to show you here is how the mean and standard deviation of a normal distribution tell you what it looks like. So as you can see here, I have graphs, again, these are pulled off the internet, but graphs of normal distributions that are in different places and different shapes. So on the top there, we have normal distributions that all have different means but the same standard deviation. So what that tells you is that the mean tells you where along that number line it falls. So where on the x-axis, if you were looking at a graph of your probability distribution, where on the x-axis that mean would be. So the first one there would have a mean of 11, the second one would have a mean of 15.5, and the third one would have a mean of 19. So the mean of your normal distribution tells you where on the x-axis that big hump of your data is. The second set of normal distributions there shows you normal distributions with different standard deviations. And just like standard deviation in the first unit told us how clumped together or spread out our data is, the standard deviation in a normal distribution tells you the same thing. And specifically, the larger your standard deviation is on a normal distribution, the flatter it is, and the smaller your standard deviation is on a normal distribution, the more it looks like this big peak like you have on the right. So that's all I got for you on the slide. Different means, different standard deviations in normal distributions. Now, in working with normal distributions, one of the main things we're going to be focused on is the area under the curve. And I briefly introduced the area under the curve in the first document camera, not the first one, the second document camera spot today. But we're going to really focus in on it a bit more now. And as I mentioned before, the area under the curve for a normal distribution always equals 1. But more importantly, it follows a rule that I'm going to say here, then I'm going to talk about what it means. And the rule is that the proportion of outcomes that fall between two values is equal to the probability of getting an outcome between those values. So as we've been talking about through this lecture, a normal distribution tells you the probability of getting different outcomes, where that probability is in a bell curve, where the outcomes in the middle are the most likely and the outcomes on the sides are the least likely. When we're thinking about area under the curve, if you were to mark off two outcomes on your x-axis and then look at the area under the curve in that probability distribution, the area under the curve would be equal to the probability of getting an outcome between those values. And specifically, there's also something called, I've been saying specifically a lot today, sorry. So there's also something called the empirical rule, which tells you the proportion of outcomes that fall between 1, 2, and 3 standard deviations on either side of the mean. So without any pictures, this slide is sort of, I think, hard to wrap your head around, which is why I keep gesturing. But because of that, I'm now going to hop back over to the document camera and show you some examples of how this works and make it a little bit more concrete.